A number of different factors ranging from worker motivation to task design choices affect the quality of crowdsourced human input. The million-dollar question that's probably picking your brain right now is how exactly can we control for quality in crowdsourcing? Well, in this segment, let's delve into a few quality control mechanisms that you can use to ensure reliable and high-quality crowdsourced data. Gold standard data is data for which the ground truth is known. These questions can be used to filter out low-quality workers, since by leveraging the fact that the true or correct response is known, you can benefit from expecting a crowd worker to exhibit genuine intentions to be able to respond correctly on such tasks. Such questions are also referred to as honeypot questions. Note that the key idea here is to ask explicitly verifiable questions to reduce the prevalence of invalid responses. So what is a good gold standard data? Or what exactly are good honeypot questions? Such questions should be unambiguous, since we want to make sure that they're effective in identifying low-quality workers accurately. They should also be scorable automatically, since we do not want to increase the manual burden of quality assessment. Time is money after all. And such questions should not be very easy to detect to ensure their effectiveness. Wisdom of crowds is the idea that large groups of people are collectively smarter than individual experts when it comes to problem solving, decision making, innovating, and predicting. The idea is that the viewpoint of an individual can be inherently biased, whereas taking the average knowledge of a crowd can result in eliminating the bias or noise to produce a clearer and more coherent result. In The Wisdom of Crowds, James Surowiecki cleverly points out the key attributes that turn the collective wisdom of crowds into a powerful instrument, those of diversity and independence. For crowds to be wise, they must be characterized by a diversity of opinions, and each person's opinion should be independent and free from the influence of others. Thus, gathering redundant judgments from crowd workers and aggregating them is beneficial in improving the overall quality of the results. Over the years, a number of sophisticated measures have been proposed to optimize and aggregate multiple responses from crowd workers on a given task. Some of the simplest but reasonably effective measures are majority voting and weighted voting. Majority voting is based on the agreement between multiple independent judgments. Assume that the task for crowd workers is to assess whether the sentiment in a given tweet is positive, negative, or neutral. The final label assigned to the tweet is quite simply the one that corresponds to the most number of votes from workers. Well, in case of weighted voting, this goes a step further by acknowledging that different workers may be differently skilled or experienced, and therefore their votes should not be equally weighed. This is therefore based on individual performance within a cohort of workers or a broader community. It is worth noting that depending on the task type, aggregating responses from crowd workers can be less straightforward. In a task where binary responses are expected from crowd workers, such as whether a tweet is only positive or negative, simple aggregation methods like majority voting can probably be sufficient. With multiple choice questions or multi-selection questions, on the other hand, we may need to consider other methods for answer aggregation. Qualification tests are widely used to ensure that crowd workers completing your tasks have a specific set of skills that you're interested in, and that can fundamentally affect the quality of the work that's produced. Requesters often use a sample task to assess and identify workers who are likely to provide high-quality responses. On the other hand, pre-screening measures can be used to filter workers based on various attributes such as their demographics, like age or gender, or experience, for instance. Pricing schemes have been explored and shown to be powerful in incentivizing different kinds of worker behavior. Pricing policies are essentially a trade-off between the task completion time and the quality of the results. To determine a task's fair price, Prior Work has proposed a data-driven effort metric called ETA, which stands for Error Time Area. It empirically models the relationship between time and the error rate by manipulating the time that workers have to complete a task. Think of this as a rapid prototyping approach. It reports the area under the error time curve as a continuous metric of worker effort. The curve's 10th percentile can be interpreted as the minimum time most workers require to complete the task without error, which can then be used to price the task. It's worth remembering, of course, that paying more increases the quantity of responses and the throughput, but not necessarily the quality of the responses. Gamification has also been identified as an effective means to incentivize desirable worker behavior. We can use game elements to engage crowd workers, improve their reliability, and increase the overall quality of responses gathered through these crowdsourcing tasks. It has been shown that there are quality-related benefits to gain through retaining the same workers in long and laborious batches of tasks. Through the use of badges, leaderboards, levels, access, power, bonuses, and similar elements, workers can be encouraged and incentivized to complete more tasks in batches, increasing worker retention, worker engagement, and contributing to positive worker experiences. Prior work has also shown how understanding and predicting when workers are likely to quit tasks and providing appropriate incentives at such moments can go a long way in sustaining workers within batches of tasks and in limiting the task abandonment phenomenon. Worker behavior can be used as an implicit signal for the quality of the responses being provided. Low-level behavioral features, such as the amount of time workers spend on tasks, how long they take to respond to specific questions or to read the instructions, whether or not they toggle windows or switch tabs, can be indicators of quality. Consider the example on your screens, where we have plotted the mouse movements and key presses of two different workers in an information finding task, where the workers were asked to search the web and find the middle names of certain individuals. The activity exhibited by a competent worker is clearly different from that of a worker with ulterior motives, who is characterized as a fast deceiver. Training workers on specific tasks has been shown to be as effective a strategy as many others in improving the quality of crowdsourced data. This can be done in a number of different ways, depending on the task and context at hand. Workers can be asked to complete a training phase before progressing onto the actual tasks. They could also receive training on failing to correctly complete specific tasks by leveraging gold standard data. Providing feedback to workers and allowing them to assess their own work, understand the errors they make, helps to improve their performance over time, while also improving the overall worker experience and satisfaction. Psychometric methods can be used to flag unreliable workers. For example, we can check for response consistency of workers across the same question that is asked at different points within the same task. Or we can also look for consistency across responses to the same questions that are framed differently. Prior works have shown how cognitive biases of workers can hamper the quality of data that is collected through crowdsourcing tasks. We recently developed the Cognitive Bias Checklist, which can be used to mitigate, assess, and report cognitive biases that are present in crowdsourced data.